The next kind of derivatives we'll look at is the derivatives of logarithms. Here our formula is that the derivative of anything of the form log base b of x is 1 over x times ln of b. So if our base is base e, so we're actually looking at the natural log, we would have 1 over x, and then ln of e is just 1. So the derivative of ln of x is just 1 over x. Now let's do some examples of using this with harder functions. Here I have ln of x cubed minus e to the 5x. So our derivative, the derivative of ln just says 1 over x. So in this case, 1 over x cubed minus e to the 5x. And then we need to multiply by the derivative of the inside to use the chain rule. The derivative of x cubed is 3x squared, and the derivative of e to the 5x is minus 5e to the 5x. So there's my new derivative. Next we have log base 7 of sine x. Since this one's not base e, we have an extra term on the denominator. We're going to have 1 over, in this case x is sine x, so sine x times ln of your base, which in this case is 7. And then we do have to use the chain rule. We need to multiply by the derivative of the inside. The derivative of sine is cosine. So I have my new derivative. And these derivatives of logs can actually also be used to help us solve more difficult derivatives. So let's look at one of those. Here I have the function ln of 8x to the 4th times the square root of 2x plus 3 all over 7x minus 1 cubed. And this can be very complicated. The fact that we have an ln of something tells me we're going to have to use the derivative of logs and a chain rule. Inside of that chain rule, you'll notice there's a product on the top, so we'll have to use the product rule. Not to mention we're dividing, so we'll have to use the quotient rule. And there are 2 different terms inside of that big parentheses that would make us use the chain rule. So we would be using the chain rule 3 times, the product rule, and the quotient rule, which can be very, very complicated. But luckily there is an easier way to do this. And the answer is to just use properties of logarithms. I can rewrite this using properties of logs as ln 8 plus 4 ln x plus 1/2 ln of 2x plus 3 minus 3 ln of 7x plus 1. Just as a reminder, anytime you're multiplying something in here, we're going to add the log of that. The bottom means we subtract, and exponents can move out front. So that's just a quick review of your logarithmic properties. So now that we have that, it's going to be much easier to take a derivative. F prime of x, or ln of 8 is just a number, it's just a constant, so the derivative is going to be 0. For this term, I would have the 4 out front, and the derivative of ln of x is x, 1 over x. Here I have a 1/2. The derivative of ln would be 1 over 2x plus 3 times the derivative of the inside, which is 2, minus 3 times 1 over 7x plus 1 times the derivative of the inside, which is 7. So if we reduce this a little bit, I have 4 over x plus 1 over 2x plus 3 minus 21 over 7x plus 1. So using properties of logs to write these out and then using the derivatives of logarithms made this problem much, much simpler.